Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 1 to 5 of the August Algebra I Common Core Regents exam for the year 2015. Don't forget, you can access the transcripts of this video on mathgotserved.com under New York Regents. All right, let's take a look at problem number 1. It reads, given the graph of the line represented by the equation f of x equals negative 2x plus b, if b is increased by 4 units, the graph of the new line will be shifted 4 units right, up, left, or down. Now let's do a real quick review of transformation of functions. We're going to just focus on shifts, okay? So let's do a real quick recall here. Now, if you have a function, if you add a constant to a function, what kind of transformation is this? If you add a constant to a function, let's say positive integer k, this results in a shift k units up, okay? If you subtract a constant, positive constant from a function, this would be a shift in what direction? The opposite of plus k, which is k units down. All right. Now, what if you have f of x plus h? What kind of shift is this? This is a horizontal shift, okay? This is a shift h units in what direction? If h is an integer, positive integer, and you have a plus, is going to be to the left. It's kind of backwards, okay? And then if you have f of x minus h, if you subtract a constant, positive constant from x, this will be a shift h units to the right, okay? All right, let's see if we can use these 4 cases to answer this question. So originally we have f of x equals negative 2x plus b. The question is, if it's increased, increment means you're adding, right? So if it's increased by 4, we're adding 4 to 2x, negative 2x plus b. How would that impact the graph? So let's start with negative 2x plus b. Now I'm going to add 4 units to this situation here. Okay? Now I know that negative 2x plus b is equal to f of x, so I'm going to just substitute that value here. So this entire piece, negative 2x plus b, is f of x. So we can simply write this as f of x plus 4. So adding or increasing negative 2x plus b by 4 units is the same thing as adding 4 to the function. Now when you add 4 to the function, what kind of transformation or shift is this? We are dealing with case number 1. Okay? That is a shift 4 units up. So plus 4, this is going to be a shift 4 units up. Okay? So that clearly shows us that our answer is option number 2. All right, let's take a look at problem number 2. It reads, Rowan has $50 in a savings jar and is putting $5 every week. Jonah has $10 in his own jar and is putting in $15 every week. Each of them plots his progress on a graph with time on the horizontal axis and amounts in the jar on the vertical axis. Which statement about their graphs is true? So in this case, we have a beginning amount and a growth rate. Okay, if you have a beginning amount and a constant growth rate, that is going to result in a line. So what is the equation of a line? Recall that the equation of a line is given by y equals mx plus b. So in order to answer this question about how the two lines compare, we need to generate the equation for Rowan's situation, Rowan's saving, and the equation for Jonah. Okay? So m is your slope. That's how much do they add, how much do they save every week, okay? And b is your y-intercept. Think about it as your beginning, b for beginning. how much money did they begin with? Okay, so for Rowan, Rowan has $50 in a savings jar. So this is the beginning for Rowan. I'm gonna call it B for Rowan. He saves $5 every week. So this is his growth rate or his slope. This is the slope for Rowan. All right, $10. That's for let's use blue here. That's for Jonah. This is how much he started with. Okay, so this is the beginning for Jonah, and he saves $15 every week. Guess what? This is the slope, M for Jonah. All right, now with the M and B for Rowan and Jonah, we can write down the equation for the two savings situations. All right, let's start with Rowan. Let's do Rowan in green. So what is the equation for Rowan's savings situation? So we know y is equal to mx plus b, so we're going to have y for Rowan equals, the slope for Rowan, m is 5. So 5x plus, what's the starting amount? How much did Rowan begin with? 50, 5x plus 50. Okay, following y equals mx plus b format. Now let's take a look at Jonah's line, Jonah's saving line. Can you see what that is? For Jonah, all we just need is his slope and y-intercept. So y, the graph for Jonah, let's call it y sub j, is equal to the slope for Jonah, m. He saves $15 every week. That's his slope. So 15x for mx plus b. How much did Jonah start with? He started with $10. That's his beginning amount, 10. Okay, so there goes the two lines for Rowan and Jonah. All right, now let's take a look at the options we have here. Option number one. Option one says Rowan's graph has a steeper slope than Jonah's. They both are positive, so if Rowan has a steeper graph than Jonah, case number one, that means that the slope for Rowan, let's do it this way. The slope for Rowan, the slope for Rowan is going to be greater than what? It's going to be greater than the slope for Jonah. Is that the case? Well, let's determine what the values are here. The slope for Rowan's savings line is 5. The question is 5 greater than the slope of Jonah, which is, what's the slope of Jonah? Slope of Jonah is 15. Is 5 greater than 15? Is it? No, this is false. So what does that tell us? It tells us that this statement, 1, is not true. Okay? All right, let's take a look at the second statement. The second statement says, Rowan's graph always lies above Jonah's graph. Is that the case? Now let's take a look at where they begin here. We're going to make a tiny little graph just to give ourselves a visual. Rowan has a higher starting value. He has a starting value of 50. Let's put it right here. And Jonah has a lower starting value of 10. But what do you notice about their growth rates? Rowan's growth rate or slope is smaller than that of Jonah. So think about two cars racing, and one is moving much slower than the other. Even though the slower car has a greater head start, what is going to happen at some time in the future? The faster car is going to catch up, given enough time. Okay, so let's illustrate that with our graph. So Rowan's line is not as steep as that of Jonah. So let's say this is Rowan's line with a slope of 5. Guess what? Jonah's line has a slope or a growth rate that's triple that of Rowan. So it's going to be steeper, just like this. So what does that tell us? At a particular point in time, Jonah's graph is going to be above that of Rowan, okay, because it's growing faster. So the question is Rowan's graph, y of r, is it always greater than Jonah's graph? And the answer is no. That's false. Initially, Rowan's graph is going to be ahead because he starts with more money, but because Jonah is saving at a quicker rate, he's eventually going to catch up and become greater than that of Rowan, so we'll be on top. So that tells us that option number 2 is false. Okay, now let's take a look at option 3. It says Jonah's graph has a steeper slope than Rowan's. Is that true or false? Well, for option 3, in order for Jonah's graph to be steeper than Rowan's, that means the slope of Jonah's graph has to be greater than the slope of Rowan's graph. Is that the case? Well, let's go back to our lines here. The slope of Jonah's graph is 15. Is 15 greater than the slope of Rowan's graph, which is what? 5. Is 15 greater than 5? Absolutely. So that tells us that our answer is option number 3. All right, let's take a look at problem number 3. It reads, to watch a varsity basketball game, spectators must buy a ticket at the door. The cost of an adult ticket is $3 and the cost of a student ticket is $1.50. If the number of adult tickets sold is represented by A and the student tickets sold by S, which expression represents the amount of money collected at the door from the ticket sales? Okay, when you're dealing with costs, quantity, unit cost problems, you want to write down your unit cost, your total cost formula. Okay, so let's go ahead and recollect this formula. You want to recall that the total cost, let's call it TC, is equal to unit price times what? Times quantity. All right, that's how you figure out your total costs. In this case, we have adults and students, so we're adding 2 individual total costs here. So in this situation, we're going to be dealing with the total costs. I'm going to call this total cost of all adults and kids is equal to what? Is equal to the total cost for adults, okay, plus what? Plus the total cost for students. Okay, so what we're going to do is we are going to determine the total cost for adults and students independently. The sum would be the total amount of money collected from the door. Okay, now let's start with the total costs for adults. All right, we're going to do that one in blue. So let's see. Total costs for adults. Total costs for adults. Let's rewrite the formula again. The formula is going to be the unit price for adults. Unit price for adults times what? Unit price for adults multiplied by the quantity of adult tickets sold. So quantity for adults. Okay? So that's what we're going to be doing. Now let's go back to the problem. What is the unit price for adult tickets? How much does each adult ticket cost? Each adult ticket costs $3. Okay, so this is going to be 3 times, what is the quantity of adult tickets sold? It says the number of adult tickets sold is A. So 3 times A will give us the total cost for adult tickets. Okay, we can write 300. So if we multiply these two, we're going to get 300A for the total cost of adult tickets. Now, what is the total cost for student? I'm just going to use STU, okay? Can you see what the total cost for student tickets is? Well, let's go through the procedure just to make sure we understand what's going on. So we're going to be multiplying the unit price for student tickets by the quantity of student tickets sold. Okay? So what's the unit price for student tickets? It says the cost of a student ticket is $1.50. So unit price is $1.50. How many student tickets were sold? Students tickets sold is given by S. So $1.50 times S gives us the total number of student tickets. Multiplied together, you have 1.50S. Okay, so what is the final result? Total cost is going to be the sum of these two. Okay, so total cost of both adult and student tickets is going to be total cost for adult tickets 3.00A plus the total cost of student tickets 1.50S. Okay, and we can clearly see here that our answer is option number 4. All right, let's take a look at number 4. It reads, the graph of f of x shown below, which function could represent the graph of f of x? So what we're going to be looking at here is the x-intercepts or the zeros of the function. Okay, so we have an intercept here that's a value at 1. We have another intercept here that's -2, and we have another intercept here, and that's 1, 2, 3, 4, -4. Okay, so those are the intercepts that we have. So how are we going to create the function? Well, in order to do this, all we'll do is we'll set each zero or root to x. Okay, so we have x equals -4, and x equals -2, and x equals +1. Okay, now a common mistake that most students make, please don't make this mistake, they simply attach x's to these roots. They say, oh, it's going to be x minus 4 times x minus 2 times x plus 1. This is incorrect. Okay, these are the zeros of the factors. The factors have to be solved when they're equal to 0 to yield us results. So we are working backwards. Okay, how do we work backwards? You set your variable equal to these roots, and then you're going to set each and every one of them equal to 0. Okay, in the first case, we add 4 to both sides to get it equal to 0. So we have x plus 4 equals 0. And then in the second case, you add 2 to both sides, and then that yields x plus 2 equals 0. And then in the last case, you subtract 1 from both sides. We're doing the reverse of the zero product property. So we have x minus 1 equals 0. Okay? Now what we're going to do is we're going to cluster together our factors. Okay? So the product of factors that yields this graph is going to be x plus 4 times x plus 2 times x minus 1 equals 0. Notice these are the opposite of these values right here. Okay, this is the correct way of doing it. Now, if you notice, x plus 2 is not distributed, but the other two factors are distributed. So in order for us to find our answer, f of x, we're going to multiply x plus 4 and x minus 1. Why is that? Because in the options, the roots that has a 2 is not distributed. So we're going to leave x plus 2 alone. All right, and then we're going to multiply x plus 4 times x minus 1. With this setup, we automatically can eliminate options 4 and option 2 because they're not x plus 2. The answer is either going to be 3 or 1. Okay? Now, if you take a look at this minus right here, you know that the last term is going to be minus 4, so you can automatically see that. Option number 1 is the correct answer. Okay? Now, let me just show you the work so that you know for certainty that that's the correct answer. Let's go ahead and expand these last two, okay? So do not touch x plus 2 because it's left alone in the options. We're going to distribute this first, outer, okay? And then we'll do inner last. Remember, you use FOIL only for binomials times binomials. All right, so we're going to have x times x is x squared plus 4, wait, x squared minus x, let's do it in order. X squared minus x plus 4x minus 1. If you simplify that, you have x plus 2 times x squared plus 3x minus, well, the last number is 4, sorry, minus 4, because 4 times negative 1 is negative 4. And we can clearly see that our answer is option number 1. All right, let's take a look at the last question in this installment, problem number 5. It reads, the cost of a pack of chewing gum in a vending machine is 75 cents. The cost of a bottle of juice in the same machine is $1.25. Julia has $22 to spend on chewing gum and bottles of juice for her team, and she must buy 7 packs of chewing gum. If B represents the number of bottles of juice, which inequality represents the maximum number of bottles she can buy? So this is another total cost problem. Okay, let's refresh our memory, even though we just did a problem on that. Recall that the total cost is the unit price multiplied by quantity. All right, so here we are dealing with 2 items, gum and juice. Okay, so let's do them independently, and then we're going to formulate an inequality afterwards. So let's start with gum. Okay, so for gum, what do we have? The total cost for gum, let's call it TCOG, or gum, is equal to the unit price for gum multiplied by the quantity of gum to be purchased. Now, what is the unit price of gum? Each gum costs 75 cents. So the unit price is 0.75. What is the quantity of gum? How many packs of gum did Julia purchase? She purchased 7 packs. So quantity is 7. So this is a total cost for gum. Okay? Now, let's shift our attention to the next item, which is bottles of juice. Okay? So, let's just call this bottles. Okay, so what is the total cost of bottles of juice that Julia bought for her team? Well, same formula, unit price of the bottle of juice times the quantity, the number of bottles of juice she bought. Okay, what is the unit price for a bottle of juice? The cost of a bottle of juice is $1.25. So the unit cost for a bottle of juice is $1.25. Now, what's the quantity? How much how many bottles of juice did Julia buy? B represents the number of bottles of juice she bought. So the quantity is B. Okay? And then this one, we can simplify it to 1.25B since it's a variable. Okay? Now, there's another stipulation in this problem, which is that she is on a budget. Julia has $22 to spend. So what does that mean? The total amount of money she spends on gum and bottles must be less than or equal to her budgetary constraint, which is $22. All right, let's go ahead and write that down. The total cost for gum plus the total cost for bottles of juice has to be what? It has to be less than or equal to $22. Okay, you can't spend the money you don't have buying stuff. You can only spend the money you have. Since she has only $22, she can't exceed this limit. Okay, so all we just do is plug in these values into this inequality and we will be done. Okay, so the total cost for gum is 0.75, the unit price times the quantity of 7. That plus the total cost for bottles, which is $1.25 times B. These combined costs must be less than or equal to 22 because that's how much money she has to spend. We can clearly see that our answer is option number 4. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found this tutorial beneficial to you, please give us a thumbs up. We'll appreciate your positive feedback. Do not forget to subscribe to our channel so you can get the remainder of this review installment. More clips can be found on mathgotserved.com under New York Regents. If you have any questions about this tutorial or any problems with your Algebra I Common Core Regents preparation, just post your questions in the comment section below and we'll be glad to help you as soon as we can. Thanks again for watching and have a wonderful day.